Hey, Math 30-2s. Okay, we're going to do some more difficult solving ones here. And then there's a multiple choice question on the next page there. Kind of brings everything together a little bit. So we want to solve this exponential. Like we solved these before. We graph the left-hand side, graph the right-hand side, find out where they intersect each other. That's a good way to verify our answer. I don't know if any of these actually specify verify your answer. No, they don't. Maybe we would do that just to double check to see if we did the correct. We could verify them by putting them back into the original equation as well to see if it works. So when I get a log is equal to a log, how we solve these ones is that it's going to get a little tricky, okay? So what I'm going to do here is you can either pick one of them to be the base, like the base 2 or base 3, or take the log of both sides. And what I'm going to do is I'm going to take the log of both sides. I'm going to go log 2 to the x minus 1, and then log, I'm going to use log base 10 because that's the easier one. You can put any log you want, but why would you? Okay. Now, because these are raised to that exponent, I can drop that down to the front. That's one of our log laws that we talked about like 2 or 3 lessons ago. Same to this exponent, I can drop this one down. Do you notice I'm adding parentheses around these? Like there are parentheses here. All of that is the exponent, so I got to make sure to keep that there. Now, this is where it gets a little bit ugly. I'm going to try to solve this. Now, you need to get these x's by themselves, but there's these weird brackets in the way. So one way to fix this is just put numbers there instead. But what I'm going to do first is I'm going to divide both sides by one of the logs. It doesn't matter which way you go. I'm going to divide by log 2 on both sides. So that's going to remove this log on this side. It makes this side a little bit easier. This side gets a little bit more complex though. But what I'm going to do is I'm just going to get that number. Log 3 divided by log 2 is just the number. So log 3 divided by log 2 is this number, is 1.58. I'm going to put that right here, 1.58. Okay, so I'm just going to put maybe 2 or 3 decimal places there. Maybe look at one more decimal place. It's 5. Okay, what I'm going to do now is I'm going to multiply that in. So it's 1.585x plus 1.585x minus 1. Okay. Now, okay, I'm going to leave my calculator open because I'm going to use that. I'm going to move things around. I'm going to move all the x's to one side and all the numbers to the other side. So let's move. Let's add the 1 over. Let's go plus 1. So it's just going to be whatever this number plus 1 is. That's going to be 2.585 on this side. And then I'm going to minus over this one with the x on it. So I'm going to minus the 1.585 x. I'm going to minus them on both sides. Now, I know the number is not very nice, but what's the number in front of the x? Well, the number in front of the x is 1. So 1x minus this number. So it's going to be 1 minus this number. That's how many x's we have here. 0.585 x's. Okay? So I'm just going to rewrite that over here. Negative 0.585 x's is equal to 2.585. Okay? Then what we're going to do is we're going to divide both sides by 0.585, get the x by itself, with the negative. The negative there. We're going to get x is equal to yeah, I'm going to do this. We do this as precise as possible. So I know this number here is 2. It's going to be 2.585. It's that number plus 1 divided by this number. So I get negative 4.419. Now, if I did that without the precision that I tried with my calculator here, let's just use the numbers that we have here, see how close we got. So 2.585 divided by negative 0.585. It was pretty close. Actually, it'd round up if I had the proper number of decimals there. So that's not too bad. Okay, so these are the trickier ones to do for these guys. So let's try another one here. I want you to try this one. The first thing you want to do before you pause the video, I'm just going to talk about this, is move this piece here to the other side of the equation. Kind of like what we did there was exponent and exponential equal to an exponential. So that's what it's going to start off as. Okay, let's pause the video and try that out. Okay, so hopefully you tried that. So we're going to take the log of both sides like we did before. So it's going to do the log of 5 to the power of x minus 2 and the log of 7 to the power of x plus 1. We're going to drop our exponents down. Okay, so those exponents are in parentheses there. And then I'm going to drop this exponent down too. Okay, I'm going to divide by one of these logs. It doesn't really matter which one. Let's divide by, because I don't like decimal numbers, like less than 1. So I'm going to get a decimal no matter what. But I want a number that's a little bit bigger. So I'm going to divide by the smaller log here. So divide by log 5. Let me just get rid of this here. Okay, so this is gone. Log 5 divided by log 5. So this ends up being x minus 2 on this side. This side here is going to be x plus 1. And then I'm going to have log 7 divided by log 5. Okay, so I'm going to go about 3 decimal places again because that seemed to work last time. So that's what I have there. I'm going to multiply this into the parentheses. I didn't do that up here. I didn't show you that I did that. So I multiplied this into the parentheses. Right. So I get 1.209x plus 1.209 with no x on that one. Okay, then we're going to start moving things around. So I'm going to minus, I don't know which way we want to go on this one. Actually, I should double check to see if that answer up there worked pretty good. I'll have to go verify them in a bit. Let's add 2 like we did. Add 2, so I'm going to get 3.209 on this side, and I'm going to minus the 1.209x to the other side. Okay, remember this is 1x here, so it's going to be 1 minus this answer. So I'm going to get, again, negative 0.209x, and then I'm just going to use the numbers I have written there, so 3.209 divided by negative 0.209, sorry. So I get x value of negative 15.354. Okay. Now, what I want to do is I want to verify these and see if these are actually good and do they actually work here. To verify these, I'm going to store this number into x. I'm going to go STO and hit x here beside alpha. So I'm going to store it into x. You can store it to any number or any letter. You usually hit alpha, then pick any of the green letters there. And then I'm going to go back to the original equation. It says 5 to the power of x minus 2. I'm going to put parentheses there. If you had an older calculator, you had to put parentheses. I hit enter. There's my number. Now, because I'm using a rounded version of the number, this number should be the same-ish. Not going to be exactly the same. So x plus 1. It's pretty close. So off by a little bit of decimals there. That's fine because we used the rounded number. That's going to be our problem for that. That's as long as they're close. Same thing's going to happen here. So what I'm going to do is I'm going to go negative 4.419. I'm going to store that into x. I'm going to verify to see if this works. So this would be 2 to the power of x minus 1. Yeah, that's a bit more reasonable number. It's not really small like the previous one. Remember, this e stands for times 10 to the negative 13, so it's a really small number. this one here, 3 to the power of x plus 1. Yeah, those are really close to each other. That's pretty good. I like that. Pretty good. Now, another way to verify you did this correctly is to graph it. So say I graph this one here, 5 to the power of x minus 2. I'm going to graph the original equation before I moved it. So I'm going to write the exact same thing here as on the left-hand side as one equation. And then on the left-hand side. On the right-hand side, I'm going to put a 0 because that's what's on that side. There's a 0 there. I'm going to hit graph. There's my graph. Now, you can't see it, but there's a line at 0, and maybe the intersection point is here. So our intersection is at -15. So if I do go second trace 5, enter, 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 it's probably going to cause a problem. Yeah, it's not going to work. But our guess is around -15. So I have to make sure my domain can at least see that. So here's my graph. Okay, now if I go second trace, intersect, enter, enter, enter. There you go. Ooh, we're off by quite a bit here. Round up to like 5.0 rather than 5.4. That's fine. I'm okay with that. They're pretty close to each other. I would accept this as a pretty good answer for this one. Okay, let's try this last question on the last page here. Yeah. Let's see what we've got here. I don't need the calculator for this one. So let's get rid of the calculator. Okay. So I want to use my log laws to try to figure out which of these down here represents this. Okay, so remember our log laws, if I add, and they have the same base, they both have base b, I combine the two by going x times y. So I can do that. Then I can use my switch, because there's no numbers in front of this log. I can switch this to what I call exponential form. So I'm doing my inverse. So I'm going to switch these two. So x, y, and this will be b to the power of 3. So I switched where those guys were. Okay. Do any of these match? Yeah, so right now that one matches. That looks pretty good. Yeah, nice. That's it. Okay, so we have one more lesson after this, and it's just going to be about graphing and more regression. So we're going to do some more regression in the next one. And I'll see you in that video.